Assalamualaikum and hi everyone. Today, I would like to discuss about post-lab on experiment 6, okay, pH measurement and its application. Okay, so first, title of the experiment here is pH measurement and its application. So we have two objectives to achieve today. First, use various methods to measure the pH of acid, bases, and salt. Okay. Objective number 2, determine the dissociation constant Ka of acetic acid. But before that, we take a look at the theory. Okay, difference between pH and pOH. Okay, so pH can be defined as the negative logarithm log of the hydrogen ion, H plus ion, or H3O plus concentration. So pH formula is pH equals to negative log concentration H plus. Okay, as the concentration of H plus increase, when you log something a very large number, therefore you will get the pH value become low. So therefore concentration H plus increase, we will get pH decrease, which means the solution is more acidic. Alright, so P here is stand for negative log. Okay, negative log concentration H plus. As for the pOH, can be defined as the negative logarithm log of the hydroxide ion concentration. So the formula here is pH equals to negative log concentration OH minus. P, remember, stand for negative log. Alright, so same thing goes to this. When the concentration of OH minus increase, when we log a large value, so you will get the value of pOH become lower. Okay, so pOH decrease and pH will increase. So the solution is more basic. Alright, so pH scale. So the solution is acidic. Okay, if the pH is lower than 7, where the concentration of H plus ion is bigger than concentration of OH minus ion. For the solution is said to be neutral if the pH is equal to 7, where the concentration of H plus ion is equal to the concentration of OH minus ion. As for the basic solution, the pH is bigger than 7, where the concentration of H plus ion is smaller than concentration of OH minus ion. So there are various methods to measure the pH of a solution. Okay, so the first method, acid-base indicator. So for example, that you can use methyl red, methyl orange, alizarin yellow, phenolphthalein, universal indicator, and so many others indicators. Right. Second method is by using pH paper and color chart. Okay. Alright. So next is pH meter. Okay. Alright. So acid dissociation constant of Ka here is referred to the dissociation of weak acid in water. So we have this equation, weak acid dissociate in water, so it will produce H3O plus and an ion. And the reaction here is reversible. Okay, since weak acid is not 100% dissociate. So when we write the Ka expression, okay, liquid is not considered in the Ka expression. So therefore, you will get this formula. Okay, so concentration H3O plus times concentration and ion. So over concentration weak acid. So this is the real example. So HCN dissociate in water. So it will produce H3O plus and Cn minus ion. Okay, right. Since liquid is constant, so it is not considered in the Ka expression. So therefore Ka is equals to concentration H3O plus times concentration Cn minus over concentration HCN. Right. As for the base dissociation constant, Kb is referred to the dissociation of weak acid in water. So let's say B here is referred to the weak base, dissociate in water. So base will accept a proton, so it will become BH plus. Okay. Alright, so whereas H2O donate a proton, so it will become OH minus. And the reaction here is reversible reaction because weak acid is not 100% dissociate. Right, so liquid is not considered in the Kb expression. So therefore, the Kb expression would become concentration BH plus times concentration OH minus, okay, over concentration of weak base. So this is the real example, ammonia, okay, dissociate in water. So ammonia, it will accept a proton from H2O and become NH4 plus and OH minus. Alright, so remember, liquid is not considered in the Kb expression, and you will get the Kb expression is equals to concentration of NH4 plus times concentration of OH minus ion over concentration of NH3. So, and one more thing, for strong acid and bases is 100% dissociate. So that is why Ka or Kb values have not been measured for strong acid and strong base. Alright, so now buffer solution. What is buffer solution? Solution that has ability to resist changes in pH upon addition of small amount of either acid or base. Right, so acidic buffer. So actually buffer is divided into two, acidic buffer and basic buffer. So acidic buffer is a solution can be prepared by mixing weak acid and its salt, its conjugate base. Okay, for example like acetic acid, weak acid, and its salt, that is sodium ethanoate. Alright, so the reaction that occur in buffer solution, so we have salt, sodium ethanoate. So any kind of salt, it will 100% dissociate. So it will dissociate into CH3COO minus ion and Na plus ions. Okay, that's why this reaction is irreversible reaction. And the arrow that we use here is unidirectional arrow or forward arrow. So meaning that, so there is no more salt, okay, in the buffer solution. Okay, next. Okay, so for the weak acid, we know that weak acid, it will dissociate partially. So that's why it will produce CH3CO minus ion and H plus ion. And this reaction is reversible reaction. Okay, because not 100% dissociate. Right, as we can see here, both chemical reaction, it will produce the same anion. Okay, so that what is called conjugate base. Yeah, here is the conjugate base. Okay, since salt is 100% dissociate, so it will contribute a larger amount of conjugate base compared to the dissociation of weak acid. Alright. Okay, buffer solution at equilibrium. Alright, so in the buffer solution, we have weak acid. Okay, alright. So, and also salt in equilibrium. Okay, alright. Okay, next. Action of acidic buffer solution to control. This is how the acidic buffer control its pH. Let's say like here we have addition of strong acid. So when a small amount of strong acid is added, the H plus ion will be neutralized by the ethanoate ion CH3COO minus, that is referred to the conjugate base to form CH3COOH weak acid, ethanoic acid. Alright. Okay. So the H plus it will react with conjugate base and form ethanoic acid. Okay, so that's why the concentration of H plus ion remain constant. Okay, Right, and as a result, there will be only a small change in pH. However, the concentration of conjugate base here, it will decrease. Okay, as the added H plus react with conjugate base. As for the concentration of weak acid, it will increase. Okay, as the product form when conjugate base react with the added H plus ion. Okay, so this is a condition for the addition. This is for addition for the strong base. Okay, when a small amount of strong base is added to the buffer system, the OH ion will neutralize by the acid, okay, to form a conjugate base. Okay. So it will form conjugate base. Okay, so hence the OH minus added is 100% concealed. Okay, and it will form more conjugate base. Okay, as the result, there will be only a small change in pH, and the concentration of conjugate base, okay, this conjugate base, so it will increase. It will increase. Okay, whereas for the concentration of weak acid, it will decrease. Since the added OH minus react with weak acid. Okay, so here is the procedure. Okay, procedure. You can watch it. So I think everyone is already watch these videos. Okay, so we can skip, or you can go to the YouTube channel Unit Kimia to rewatch again these videos. Alright, so this is the result for part A, number 1A. Alright, so for this part, you have to use pH paper, okay, to determine the pH of this solution. So this is the result, and then you have to compare with the pH indicator test strip, and then write what is the pH values here. So this the number here is referred to the pH values. Okay, next for result part A, number 1B. So for this one, you have to use pH meter, okay, to determine the pH of this following acid. So between HCl, different concentration, and ethanoic acid, also different concentration. And this is the values of the pH. So we can see that the pH meter can read until 2 decimal places. Okay, for part A, number 2, okay, so you have to use two indicators here, methyl red and methyl orange. For these three solutions, HCl, ethanoic acid, and ammonia. And these are the result. You have to compare the color here with the methyl red charge and methyl orange charge. Okay, so and then write what is the values of the pH. Okay. Alright, so for part A, number 3. Alright, so you have to use indicator alizarin yellow to determine the pH of sodium hydroxide and ammonia solution with different concentration. Here is the result. Compare with the alizarin yellow and record the pH value. Alright, so for result part C, you have to use two methods between pH paper and also universal indicator. Right, so here is the result for the pH paper. Okay, and then of course you have to compare with the pH indicator test strip and then record the pH reading here. Okay, alright, next for the universal indicator result, so you have to compare with the universal indicator chart provided here in this picture. Okay, so there are three kind of salt here, and then you have to determine whether the salt here is neutral, acidic, or basic salt. Okay, for part C, okay, this one is the preparation of buffer solution. Alright. Okay. So after have mixed conical flask X with Y, okay, so the buffer solution will form. Okay. So inside of the conical flask X is referred to the conjugate base or the salt, and then it will react with inside of Y here actually is weak acid. So when mixed together and it will form buffer solution, and then by using a pH meter, so you have to determine the pH of the buffer solution, and the reading here is 4.5. pH here is 4.5. So for calculation part C, so we already know the buffer solution at equilibrium. So it contains weak acid and also conjugate. Okay, that came from the salt. Right. So this is the weak acid, and conjugate base here come from salt. Right. So you have to use the concentration that is come from the conical flask Y for the weak acid. As for the concentration for conjugate base is referred to the conical flask concentration conical flask X. Okay, so the value are the same here. So now we want to calculate the Ka values for acetic acid. So you have to use Henderson-Hasselbalch equation. So here is the formula. Okay. Alright. So next, pKa. P here is stand for negative log. Ka. Alright. Okay, next, substitute the values. Conjugate base, we have 0.1 concentration. And weak acid also 0.1. Okay, next, so we know that log 1 is equal to 0. So therefore we get pH equals to negative log Ka. And the pH we obtain here is 4.5 equals to negative log Ka. And then you have to find out what is the value of Ka. Alright, so this is for discussion part A. So for discussion here, you have to you have to answer in your lab report. Okay. Alright, so state the method used to determine the pH of acid and bases in part A. State the indicator used to determine the pH of acid and bases in part A. Identify the strong acid, strong base, weak acid, and weak base used in part A. And then which method is the most accurate to determine the pH of acid and bases? Right, so next for part B, based on the result obtained, state whether the salt solution acidic, basic or neutral. Okay, next, so this is discussion for part C. So first you can mention about what is buffer solution. State the species present in conical flask X after the titration. State the species present in the buffer solution, which means buffer solution at equilibrium. Alright, next state whether the buffer solution form is acidic or basic. And explain how does a buffer solution maintain its pH before and after the addition of strong acid and strong base. Name the formula used to calculate the pH of the buffer solution. As for the conclusion, right, so you can write like this. The method to measure the pH of acid and bases and salt are, so what are the method? Okay, the most accurate method to measure the pH of acid, bases and salt is, choose one method. Okay, the dissociation constant Ka, write the value that you have calculated in the calculation. Okay, right, so that's all. Okay, thank you. And we see you again next semester. Bye.